If you would not be restricted to the resources, facilities, and equipment at tech and at the company, what other resources will you use? And the second question is, what will be the ideal scenario for the developing of your project? Justify your answer. To answer the first question, there were many outcomes to the experiment. The first scenario that our team thought about was using a divinyl sulfone as a crosslinker between the Aptus molecule and the amino acid. Unfortunately, Tech did not have the divinyl sulfone, so we had to find another stable polar molecule that would link to the amino acid. Furthermore, if we did go through the divinyl sulfone method, we would have to create a buffer with pH higher than the one we had. The one we had 7.6 pH, and the divinyl sulfone needed at 9.6 pH. This comes at the cost that it would have been a shorter process, but it would also be a more expensive product since divinyl sulfone cost almost double that of the already expensive formaldehyde. What would be the ideal scenario for developing of your project? If we actually went through with using divinyl sulfone, it would be in fact the ideal solution to the project. Formaldehyde has the property of joining with an amino acid with two or more amino groups without losing polarity. With DVS, we should have the ability to join basically every amino acid with a change without losing polarity and remaining soluble in water. This is thanks to the middle sulfur group having two oxygens side by side that will charge the polarity of the nanoparticle, ensuring its polarity, not important of the end of the chain. All this information came from the paper that Han Ki Wang created. This reaction will give us the ability to furthermore create more versatility in the project, joining in the molecules with amino acids or proteins that have an amino group at the end of the chain, as stated and seen on the next reaction.